Hello everyone. I would like to thank each one of you for sparing your time and joining us live. With immense pleasure, I would like to invite Dr. Balamurugan, Associate Professor of AAA Department, Amrita School of Engineering. He has done a specialization in power systems and has been recently awarded with the National Innovative Teachers Award. We welcome you, sir. So my first question to you is, how did you feel when you were receiving this prestigious award on the stage?
It's so natural that it's a very proud moment for me, right, to receive that national award, the two particularly for a teacher, right, to an innovative teacher, receiving that award from Javadekar, who is the HRD minister, right. So it's really a very great and a proud moment, right. So which I can cherish in my life, and whenever I think about it, right, it makes me so happy and more comfort, right. Uh, so I am called to Delhi in January 19, 4th of January 2019. We had a award ceremony at New Delhi, and in the ceremony, Shri Javadekar, HRD Minister, has given away this Innovative Teacher Award.
Great, sir. So can you tell us about the selection process?
Okay. Basically, this award scheme, it's given by MHRD. They have a scheme called as Pandit Madan Mohan Malaviya Teacher and Teaching Award. That's the scheme what they have. And this particular thing has been given to Administrative Staff College of India, Hyderabad. They did the selection process. So it's a three-stage process. So what this ASCII they did it for MHRD is they received the application from the faculty, from the teachers all over India, from different discipline, from engineering, physics, chemistry, science, arts, pharmacy, medicine, from all the things above +2. They collected the application from the faculties, and they did the scrutiny. From that, they selected nearly about 75 have been selected, and the 75 people were pushed to the stage 2. In the stage 2, we were given a questionnaire, and we were asked to give some much more information about the what innovative teaching we are doing here. We were asked to give a little bit more information. They verified all those information, and at the stage 2, 15 people were shortlisted, and we 15 people were called to ASCII Hyderabad, and we had a interview session there with the MHRD officials, and some vice chancellors were there. They did the interaction with her, and out of this 15, 7 people were chosen for this Innovative Teacher Award.
Right, sir. So would you like to tell us what was that special, innovative, more like unique element in your project that led to you receiving this award?
Okay. Basically, I work on power systems. Even when I do my UG or PG, even during my PhD, right, we do whatever thing we do in power systems, we do only at the simulation level. So when we are doing everything at the simulation level, we feel little difficult to bring it to the real time. Even if you have some thinking process to get it done, you will not have the infrastructure to do it. And even the physical sense of the power systems, you will not get it when you do it through simulation or only through textbook study. So this thinking process, what has made us to do is, let us bring the actual power system, that is generation, transmission, distribution, whatever we are seeing. We decided to bring it down to a scaled down model, which we can keep it on the table so that we can work on it. If any students want to contribute something on the scaled down model, they can implement it and they can see the results. So basically the idea behind this is to make the students to get the physical sense of the power systems, and whatever they want to contribute, they can easily contribute if a real system is there on a scaled down level. And that is the basic idea behind this. So this made us to move the laboratory from simulation laboratory to the power systems hardware lab. That's what the innovation behind this laboratory.
Okay, sir. So would you like to explain the facilities that are provided in the power system lab?
Okay. The facility, the starting point of this laboratory is, the major challenge is to bring the transmission line into the laboratory. So we have the facility there. That is, we have a transmission line. Normally, the transmission line, it will be of very high voltage, that is of 400, 600, 1000 kV. So here, what you are seeing here, it's a transmission line. Whatever you see on the roadside, the same transmission line it is. The rated value is 230 kV, 230 MVA, 300 kilometer transmission line. We have scaled it down and we bring it to the tabletop. So this complete set makes one transmission line of 300 kilometers length long. So whatever result you are going to get on the real transmission line, the same answer you will get it here. So this is one of the basic fundamental facility what we have created here. And this is not the facility what I did of my own. There is a very big team behind it, and they supported me in making it. And everything has been initiated by our professor, Dr. TNP Nambiar, who was the backbone of this thing. And this design part, initial part, we got the support from Dr. Jayabharati, who was also working on this line, who made it happen. So this is the basic thing which is essential for this laboratory is concerned. So once if the basic thing is ready, then controlling all those things or analyzing the transmission line, analyzing the distribution, analyzing the generation, all those things, it was so simple. So this is the basic facility. And if you want to do any control on this, if you want to analyze something on this, we use some compensators. We have shunt reactors, which will be used for controlling the power flow in the transmission line. We have shunt capacitors. These shunt capacitors are used for controlling the voltage in our power systems. So that also we have. So all those things we fabricated in our laboratory. That line, these compensators, or we made everything of our own. We did the design, we fabricated it, and we tested, we calibrated. Everything is done in this lab itself. So we have enough lab supporting faculty. Once if you give the design to them, they will make it, and they may make it available in the laboratory. So here, I think I have to mention my lab staff, that is Rajinikanth and Balasubramaniam. They are the backbone of making all those things. If you just give the design, they make it, and they will make it available in the laboratory. So in connection to that, we have some series injection transformers. So these series injection transformers will help us to do series compensation. So that also we designed as per our requirement. Then apart from that, this is a basic thing. Wherever you go to any generating substation, they will synchronize the generator to the grid. So for that, they use synchroscope. So this is the synchroscope what we are using in our laboratory for the parallel operation. So this is only a part of the facility what we are having right now in the lab. What you're seeing is only a part of this thing. Apart from this, we have many more facility, but basically this is to make the students to understand, to get the physical feel of the power system characteristics. So this is only at the textbook level study. Beyond this, we have one more infrastructure, which is basically for doing research, that is a IEEE fiber system. So I will just explain you about that IEEE fiber system, what we have in our laboratory. So what you can see here, this is IEEE fiber systems, which consist of 5 buses. So this complete setup is given by the IEEE. It's a standard system which is given by IEEE, but what we did is we brought it to the reality. This complete setup was designed at Amrita, fabricated everything, testing, everything is done at Amrita. So here we have 5 buses and we have 7 lines. All the 7 lines are connected. And for this thing, you can energize this fiber system by using the sources. We have generators here in the lab. Using that, you can energize this fiber system. Apart from this, in the rooftop, we have solar, we have wind. From the solar and wind, the supply will come to the panel at the backside. Through that, you can energize the system. So renewable energy interfacing is possible. Apart from that, next we have a renewable energy technology laboratory. That lab and this lab is interconnected. If you want, you can take the supply from there. If you want to supply from here, that is also possible. And on this, we want the students to do some data analytics. For that, we have given 2 provisions. One is you can find a digital meters kept at different parts. This is a data-enabled meter. So it will give you the accurate data in a RS-485 communication protocol. So students will collect the data from this. And we have CT and PTs are connected at all the nodes of this power systems. So what we do is, that is for the transient analysis. We pick the information from this and we will give it to the computer using a National Instrument DAC. From the DAC, from the system, they can do the complete analysis about the power system. Even if they want to do some control also, they will directly do it. So this is a basic fundamental facility what we have created here for the students to do some research in this laboratory. So this is what about the facility. and it will not be getting completed if I'm completely sharing my own thing on this power system lab. Apart from that, if you can hear from the students who already did some experiments here, if they can share their experience with you, then it will be more appropriate for you to understand more about this laboratory. So over to the students.
Would you like to introduce yourselves to the audience?
I'm Vaibhav Krishna, final year triple E.
I'm Mahita from 4th year triple E.
I'm Naveen from final year triple E.
So would you like to share your experience of how joyful, how nice it was working with Sir?
Sir has always been a source of inspiration for us. Right from the story behind the development of this lab, like when we came the first year, this lab never existed. So this lab grew along with us. So throughout the 4 years of our study, this lab grew with us, and today we have this lab with us. And getting to this lab was just because of Sir, because he was a source of inspiration to us. He wanted this lab to, he wanted our students to get to know what things happen in the real world, because till then we were doing everything on the simulation side.
So my question to you is, how would you like to compare the power system lab to the other labs, keeping in mind the practical and theoretical concepts?
We learn subjects like power systems, electromagnetic theory, control theory. So when we learn all this, we've always been using simulation softwares and doing equation-based models to visualize or realize those systems. But then after the implementation of this lab, we've been able to understand what goes on a practical basis. For example, we can understand the entire transmission system, the power system, and we also know concepts like Faraday effect and many others. So instead of simply depending upon simulations and equation-based models, we started realizing what a physical response would be from the system itself.
So my question to you is, how do you feel working in this lab?
Well, earlier I was wondering how the power is transmitted through the transmission lines and how the current can be flowed in whatever direction we require, and what are the concepts regarding overloading and how the short circuit occurs. Though all these concepts were theoretically taught in class, we were not having the practical idea of how this works practically. So after working with this lab, it's all clear for us now. And what we actually have in this lab is that the scaled down version of the overhead transmission lines, which we see daily over the roads. All those functions that are applicable to those transmission lines can be done physically in this lab, and it's like we can feel the physical sense here. And one more thing is that after graduation, few students may get into the electricity board companies where they have to work at the substations. Without the practical knowledge, we can't work over there. And they, as the freshers, they would feel hesitate to work with those equipments. But now we have got the skill to handle these equipments without fear. This is the major advantage for us. So according to me, for all those students who are passionate towards the power systems, working with this lab would trigger them towards the research field.
Okay. So the next question is, what are the projects you would like to state, and how this lab is different from the other labs?
Unlike other power systems laboratories, this lab has a provision to explore different fields, not just electrical, but electronics and computer science that can be applied in power systems. Many projects involving IoT incorporation in power systems, or also known as smart power systems, have been performed here, which is still a mystery to others. Also, projects have been done on data acquisition using LabVIEW, frequency control, real power flow control on the IEEE fiber system, which mentioned earlier. According to me, it is that IEEE fiber system is a real-time representation, or also could be seen as a mini version of a power system within an area. This, I assure, can be rarely found in other power system labs. So this may seem Greek and Latin to the freshers who are viewing this video, but still, even if they have a teeny bit of curiosity, this lab provides a beautiful platform for them to develop their curiosity into interest, and this lab helps them to excel in it.
Great. So back to you, sir.
Yes.
So what are the upcoming projects and the future plans for this lab?
Okay. Now the things are, technologies keeps on getting updated. So we also want to move to the next version of this laboratory. That is what we are looking for. So apart from simply going with the Faraday effect, as he stated, Faraday effect, surge impedance loading, shunt, the series compensators, then basic fundamental control, whatever they do in the classroom in the theoretical teaching. Apart from that is what right now we are doing in the laboratory. But the future is these students are nowadays much more interested on IoT control from the web, data analytics, then physical systems. So their interests are moving towards that thing. So we want to bring that into this laboratory. So we are planning to move towards the version 2 of this laboratory with more data analytics, with more cloud computing, with more IoT application. That is what is our plan is. So even we got a funding from the IETE to move from this version 1 to version 2. So we have a detailed plan for it. So these juniors are concerned. So they, apart from this regular lab, they will be having the IoT based power systems lab with more data analytics and more real-time control from modern tools. That is what they are going to do it. And modern tool means specifically we are going to use LabVIEW, we are going to use Arduino, Raspberry Pi. Using this, they will be doing the control. So that is what the flavor we are trying to give it into this lab on the version 2. Then apart from this, we don't want this facility to be limited only to the EEE students of Amrita School of Engineering, Coimbatore. We want this facility to be made available to the other students also. So we have the plan of floating a summer internship for the other students. So if the students from other institute, if they want to come and work here in this lab will be kept open 24/7. They can approach us. We will give them mentor. We will give them all the infrastructure, whatever facility they want. We will provide them everything. There is no time limitation for it. And we have listed some of the problems also. It's a general thing. But if they have their own idea, with that idea also, they can come here. We will support them to get it done. So their problems, we are looking for a hardware-based solutions, and also we are looking for simulation-based solutions. Arduino, Raspberry Pi, or Node MCU, these kind of devices they can use, and they can use the power-related sensors like voltage, current, speed. Those things they have to sense it, and we want them to do computation and make the data available on the cloud. And they want to apply some applications. Applications can be a data analytics. It can be some control. It can be some congestion management. It can be some load frequency control. So those things we expect them to do it from the cloud layer. So these are the problem statements we have given. So the people from other institute also, if they are interested, they can come and do their internship in this lab. We are open to it.
Sir, raising a question from the audience point of view, is the usage of this lab limited to the electronic students, or is it open for all?
That is another important question, I feel. This power system is not just for BTech, BTech or BEEE students, right? Now on this fast change of the technologies, only EEE students alone cannot work on this power systems. We want the other department people also to come and contribute for this power systems. Only then this lab can get developed. For example, when you want to make your power system to be completely smart, we need the communication people to come and do their contribution. We want computer science people to come and do some support on the cloud computing and other thing. Even the cyber security also they have to come and provide. Then we want the instrumentation people to get inside, and they have to do the support on the instrumentation, data signal processing, all those things we want them to do it. And if you want to make the power system to be more efficient, completely smart, it's going to be an interdisciplinary area. It's not just for EEE. Other people also, they have to, other discipline people also has to come and contribute it on it. Then only it will grow further. So these are the, so we are looking for the people who want to grow on artificial intelligence, then cyber security, data analytics, blockchain technology. These are the current technologies. So these people, those who are interested on these areas, they can definitely come here and they can make use of it. So coming to straight to your answer, it's not just for EEE. Only if all the other department people come and contribute their ideas into this lab, only then the power system will grow. The power system can reach the ultimate either smartness.
Thank you so much, sir. And thank you, everyone. So that was our interview. If you have any queries for sir or related to power system or anything else, You can post your comments in the comment section below. Thank you so much. Have a nice day.